Good morning, students. Finish your prayer. Thank you. நான் ஒரு நல்லாசிரியர். நான் உங்களுக்கு தாயாகவும் தந்தையாகவும் இருந்த முறையாக அன்போடு கல்வியை போதிப்பேன். நான் ஒரு நல்லாசிரியர். நான் உங்களுக்கு தாயாகவும் தந்தையாகவும் இருந்த முறையாக அன்போடு கல்வியை போதிப்பேன். நான் ஒரு நல்லாசிரியர். நான் உங்களுக்கு தாயாகவும் தந்தையாகவும் இருந்த முறையாக அன்போடு கல்வியை போதிப்பேன். Take your social science book. Come to page number 162. So today we will see about earthquake and tsunami. So have you faced or have you seen earthquake or tsunami? No chance for us. So because we are in the earthquake risk zone, and since there is no ocean or sea coastal area near to us, so we can't face tsunami. Okay, but so let us learn about tsunami and also earthquake. So how it happened? Yes. What was the process behind the earthquake and tsunami? So move into the lesson. So before entering to the class, just to recall what we have discussed in our previous class. So first we saw about the geomorphic process. So geomorphic process means the physical process which have an effect of the surface of our earth, that is which changed the surface feature of the earth was called as geomorphic process. So which may be internal and external. So the geomorphic process may be internal or external. Then we saw about the plate tectonics, that is the movement of plates, and also the types of plate boundary. So there are several major plates and minor plates, so that float over the mantle, so which have several type of boundary, that is convergent, divergent and conservative boundary. Then we saw about the movement of continental plates. So that is the plates are moving on the mantle floor. So the continental plates are moving. So because of the plate movements only, so different relief features, so different surface features of the earth was formed. So in that we saw about how India, which was a part of Gondwana land, separated from that Gondwana land and collide with Eurasian plate, and thus the formation of Himalayas. So we saw about that and all detailing. So in today's class we will move to the earthquake and tsunami. So what was the reason behind earthquake? So we saw about detailing. So earthquake. So what is an earthquake? So the sudden vibration of earth surface was called as earthquake. So the earthquake means so nothing but the sudden vibration. So sudden vibration of earth surface. Okay. So earthquakes are generally caused by the sudden vibration in earth crust, which spread outward in all directions. Okay. So earthquakes are generally caused by the sudden vibration in earth crust, which spread outward in all directions as the waves from the source of disturbance. So from the source of disturbance, a wave spread over all direction, so that caused a vibration in earth crust. So the point of origin of earthquake is called as focus or hypocenter. So you can see this picture. So focus. So in that point only earthquake originate, and the place so where we feel was called as epicenter. So the point of origin of earthquake is called as focus, so which generates a series of elastic waves. So from that a waves, so a movement so begins, so that reach a point on the surface of the earth which was called as epicenter. So the impact of earthquake is felt most at the epicenter. So we are at the point of epicenter. So we feel the most impact, so the most effect of earthquake was feel in the epicenter. So earthquake means so a general wave, so that is caused by the earth vibration. So earthquakes are generally caused by the sudden vibration in earth crust, which spread outward in all direction and the waves from the source of disturbance. So the point of origin of earthquake is called as focus, so that generates a series of elastic waves. Then epicenter, it is a point on the earth surface that lies directly above the focus. So the impact of earthquake was felt at epicenter. So we saw the elastic waves that was generated from the point of origin now. So that elastic waves was called as seismic waves. So the earthquake generate seismic waves. So the nature, force and speed of the seismic waves depend on the nature of the medium through which it passes. So the nature and force and speed of the seismic waves depend on the nature of the medium through which it passes. So based on the nature, force and speed, the seismic waves are divided as three major types. So accordingly there are three major types of seismic waves. So let us see one by one. So first one is called as primary or P waves, second one is secondary or S waves, then third one is surface or L waves. Primary or P waves. So fastest of all the earthquake waves, and it was the first to reach the epicenter. Yeah. So primary or P waves, it is the fastest of all the earthquake waves and was the first to reach the epicenter. So these waves pass through solid, liquid and gases. Okay. So these waves pass through solid, liquid or gases either through push or pull. So and it has an average velocity, average speed of 5.3 km per second to 10.6 km per second. So primary or P waves are the fastest of the earthquake waves and it was the first to reach the epicenter. Yeah. If you see the movement of these P waves, so shown is in this picture. Yeah, so it was moving just like compression, relaxation, compression, relaxation. Yeah, so it goes in a straight line. Okay, so it goes in a straight line. So like so it compressed and relaxed, compressed and relaxed. Yeah, so like that it was going. So primary or P waves. Yeah, so the speed of this P waves, primary waves was 5.3 km per second to 10.6 km per second. Okay, so then it passes through all the medium, that is solid, liquid and gases, and it was the first wave to reach the epicenter. Then secondary or S waves, so which travel only through solid. Yes, so primary wave travel through solid, liquid and gases, whereas the secondary wave travel only through solid. So these transverse waves shake the ground perpendicular to the direction in which they propagate. Yeah, so these waves shake the ground. Yeah, so perpendicular to the direction in which they begin. Yeah, so these are like a transverse waves, that is it contains up and down motion. Yeah, so you can see in this picture, so it goes up and down, then goes up and then down. Okay, so then the average velocity of these waves is 1 kilometer per second to 8 kilometer per second. Yeah, so what was the velocity of primary waves? 5.3 kilometer to 10.6 kilometer. Yeah, whereas the secondary waves velocity was 1 kilometer per second to 8 kilometer per second. So surface waves or L waves, which are similar to P waves, but they travel primarily along the ground surface. Okay, so surface waves travel primarily along the ground surface. So these waves travel comparatively slower and are the most destructive waves. Yes, so when compared to primary waves and secondary waves, so surface waves are so very slow, but they are most destructive waves. Yeah, so the average velocity of these waves are 1 kilometer per second to 5 kilometer per second. The average velocity of surface waves is or L waves is 1 kilometer per second to 5 kilometer per second. Yes, you can see in this picture, that is the movement of the L waves. Yes, it is their movement is also like S waves only, just but it is very slow. Yes, up and down is very slow, but they are similar to primary waves. So in its direction it is similar to the primary waves. So CF Richter, so who devised a scale to measure the magnitude of earthquake. Yeah, so in news you can hear no, in Richter scale it was measured as 7, in Richter scale it was measured as 8 no. Yeah, so it was designed by CF Richter. Yeah, so this scale relates to the energy released at the epicenter and provides an estimation of the severity of earthquake. Yeah, so the severity of earthquake was estimated by Richter scale. Okay, so it is an open-ended scale. Okay, in this slide you can see, so based on the Richter magnitude, so what was the effect of earthquake? Okay, so from 0 to 8, then above 8, so what was the effect of earthquake? So based on the Richter scale. Okay, so shown in this slide. Then the instrument which records the earthquake waves is called a seismograph or seismometer. Yeah, so the science that deals with the earthquake is called as seismology. So the instrument which record the earthquake waves is called as seismograph or seismometer. Then the science that deals with the earthquake is called as seismology. Primary or P waves. So fastest of all the earthquake waves, and it was the first to reach the epicenter. Yeah. So primary or P waves, it is the fastest of all the earthquake waves and was the first to reach the epicenter. So these waves pass through solid, liquid and gases. Okay. So these waves pass through solid, liquid or then the tsunami. So the waves from ocean. Yeah. Okay, students, try to know the Tamil name of tsunami. Yes, a tsunami, it is not a Tamil word, it is a Japanese word. Yeah. So try to know about the Tamil name of tsunami. So in your previous classes, that is in your 8th standard, 7th standard, you know about tsunami. So the word tsunami is a Japanese term. Yeah. So which mean harbor waves. Okay. So su means harbor, nami means waves. So you have learned in 8th standard, 7th standard itself. Yeah. So it is adapted to describe the large seismically generated sea waves. Yeah. So it is described to describe the large seismically generated sea waves which was caused by earthquake, submarine explosion and landslide. Yeah, so how tsunami occur means, so because of earthquake. So if there is a earthquake occurs in the ocean floor. Yeah, so you know there are several plates, yeah, so that floats on the earth which sometimes meet in the ocean floor. Yeah, so if there is any earthquake means, so that push the water up. If the plates so move away, yeah, so the if the plates move away means, so there is a pressure. So you know, so interior of the earth contains a huge heat and pressure. Yeah, so that pressure pushes the water up, that reaches the coastal region as a tsunami. So that reaches the coastal areas as the higher waves. Yeah, and also submarine explosion. So if there is any explosion, that big explosion or any asteroids, so that big asteroids, so that fall on the oceans means, so it also generate waves. So it also generated sea waves. And also if there is any landslide, so any big landslide near the coastal region means, it also result in tsunami. Okay, so these waves travels at a speed of more than 500 kilometer per hour. Yeah, so the speed of this tsunami waves was 500 kilometer per hour, and also the length of the waves exceed 600 kilometer. So the length of the waves exceed 600 kilometer. Sometimes the height of the waves was more than 15 meter near the seashore, so and are capable of causing destruction along the coastal area. So the tsunami waves reaches a height of 15 meter, so in the coastal region, and can cause a lot of destruction along the coastal area. The 2004 Indian Ocean earthquake, so that caused tsunami, which is the sixth deadliest natural disaster, traveled at a speed of 600 km per hour. Yeah, so you might know about the tsunami. So the word tsunami became popular in India only after 2004. Okay, ma? So in that year only, yeah, tsunami waves that hit India. Yes, India was worst affected by that tsunami waves. Yeah. So how it happened means, so there was an earthquake in Indian Ocean island, so in which the Richter scale was measured above 9. Yeah, so above 9 it is very worst. Okay, so there was an earthquake in Indian Ocean near Indonesia. Yeah, so from there the tsunami waves began and reached India only after 7 hours. Okay, so the earthquake which occurred in Indonesia nearly 0.58 hours, that is at midnight. So at midnight nearly 1 o'clock the earthquake occurred, and the waves generated there reach India, reach Chennai after 7 hours. Yes, approximately by 8 o'clock only, so the waves reached. Okay, so the death toll of that tsunami was 2,80,000. So approximately 2,80,000 people were died because of that tsunami. Yeah, so it happened on 26th December 2004. Yeah, so it was nothing but it was a meeting place of India Australian plate. Yeah, so Indo Australian plate with the Eurasian plate. Yeah, so the Indo Australian plate subducting, that is, it goes down and the Eurasian plate moves up. Yeah, so that pushes the water. Yeah, so that the waves traveled across the coastal region of many countries. Yeah, so in this picture you can see the affected countries of tsunami of 2004. Yeah, so it was nothing but the movement of plates. So the Indo-Ocean plate so goes down and the Eurasian plate so moves up. So that pushes the water up, that reaches the coastal region as the tsunami waves. Students, we saw about earthquake and tsunami. Yeah, so if the earthquake so that happens in ocean floor means that may cause tsunami. You know, so if there is earthquake in land continental region means so there is no chance for tsunami. But if the earthquakes that took place in ocean floor means so there is a chance of tsunami, but all earthquakes in ocean does not cause tsunami. Okay, va? Then so try to gather information about earthquake and tsunami. Okay, va? So if you have any doubt, contact me. So finish your homework. So take care. Thank you.
Earthquakes. An unexpected movement of the Earth's surface is called an earthquake. When two parts of the Earth's surface move suddenly in relation to each other along a fault line due to tectonic forces, an earthquake occurs. A tremendous amount of energy is released in the form of tremors and vibrations. Such earthquakes are called tectonic earthquakes. The point of origin of an earthquake is called the focus, while the point directly above it on the surface of the earth is called the epicenter. Owing to the strong vibrations around the point of origin, the degree of destruction is greater around the epicenter. The branch of knowledge that deals with the study of earthquakes is called seismology, and the experts who study seismic waves are called seismologists. There are three types of seismic waves that spread in all directions from the focus. They are the P, S, and L waves. The compressional waves are the first to reach the earthquake recording station as they travel 1.7 times faster than the shear waves and are therefore called primary or P waves, while the shear waves are called secondary or S waves. The primary waves cause the particles of rock to vibrate forwards and backwards in the direction of the waves. Secondary waves, on the other hand, cause the particles to oscillate at right angles to the direction of the waves. When P and S reach the surface of the earth, they get converted into L long waves that travel along the surface, vibrating horizontally at right angles to the direction of the waves, called love waves or Rayleigh waves, as they also travel like sea waves. The most violent shocks and subsequent destruction is caused by the L waves. The instrument used to detect and record seismic waves is called a seismograph. The recorded material appears like a graph and is called a seismogram. Based on the depth of their foci, earthquakes are classified into three types. They are deep focus earthquakes that occur at depths exceeding 300 kilometers the reasons for which have not yet been identified. Intermediate focus earthquakes with depths of foci ranging between 55 and 300 kilometers. Shallow focus earthquakes with depths lesser than 55 kilometers. To measure the magnitude of the earthquakes, a Richter scale is used. The point scale is arranged in such a way that each of the units on the scale is equivalent to 30 times the energy released by the previous unit. While a magnitude of 2 is seldom felt, a magnitude of 7 indicates the lower limit of an earthquake that has a devastating effect over a large area.